When we hear smart revolution, we picture a refrigerator that orders milk or a watch that tracks our heart rate. But defining the Internet of Things by consumer electronics is like defining the combustion engine by a lawnmower. It misses the scale of the technology. The true Internet of Things is a rigorous, software-defined framework that connects physical hardware directly to cloud-based logic. At its core, true IoT is the massive-scale convergence of hardware telemetry, cloud infrastructure, and predictive analytics operating in real time. To understand the actual power of this technology, we have to look past the smart home and examine the hidden networks that are quietly redesigning global industry. To see how we get there, we must understand device intelligence exists on a three-tiered evolutionary spectrum. At the base level are smart devices. These feature simple local automation, like a coffee maker programmed the night before. The critical limitation here is isolation. A purely smart device operates entirely on its own and requires absolutely zero network connectivity to function. Move up one tier and you get smart connected devices. This introduces remote control and monitoring capabilities to the hardware. Think of a security camera or a light bulb that you trigger from your phone. To achieve this, these devices rely on active communication protocols, like a Bluetooth connection, an LTE cellular network, or a Wi-Fi signal, to transmit data directly back to the user. Finally, at the top tier, we reach true IoT devices. These are software-defined products that fuse physical hardware with continuous internet-based analytics. We are no longer talking about single appliances. We're looking at entire factories and city blocks. This tier creates exponentially more value because the systems are scalable and constantly upgradable. Instead of waiting for human input, they actively use the data they generate to execute automated, predictive logic. Reaching true IoT status requires a device to transcend simple remote control. It has to become a reactive node within a much larger, future-ready ecosystem. What separates an isolated smart machine from a true IoT ecosystem is a highly specific three-step data architecture. It starts with the physical hardware. In step 1, sensors extract raw, real-time telemetry data from their environment, like temperature, motion, or vibration, and transmit that stream upward. In step 2, this massive influx of raw data hits a centralized cloud architecture. The cloud receives the chaotic packets, aggregates them, and organizes them into a structured format. Finally, in step 3, the system applies analytical algorithms to that structured information. It can visualize trends for human operators on a dashboard or automatically trigger a mechanical response back down at the hardware level. Because this entire loop happens in milliseconds, it allows industrial systems to completely shift their operating model from reactive monitoring to proactive intelligence. This continuous, closed operational loop is the exact engine that transforms inert physical assets into high-value digital insights. To see the true return on investment for this loop, we have to scale it up to macro infrastructure. Let's look at how the energy sector applies this architecture. Enel is an Italian multinational energy company managing a massive, highly complex physical power grid. To keep that grid online, they deployed a specialized predictive maintenance application across 5 of their primary control centers. The scale of their data collection is staggering. The system constantly pulls in real-time network sensor status, individual smart meter readings, historical asset maintenance logs, and even live weather patterns. A human operator couldn't process that volume, but cloud-based AI synthesizes all those disparate streams simultaneously. By cross-referencing the data, the system predicts specific feeder failures before the physical hardware breaks down. Fabio Veronese, Enel's head of infrastructure, points out a crucial detail. Deploying advanced sensors to feed machine learning gateways is a fully operational present reality. There is nothing futuristic about it. This sophisticated model of data reading brings enormous, measurable benefits to overall grid efficiency, drastically reducing outages and lowering maintenance costs. At the enterprise scale, the true value of IoT is predictive foresight, using data to eliminate downtime before it ever disrupts the physical world. We see the exact same architecture optimizing millions of moving physical assets in the transportation sector. Take the Omnibus Fleet Operations Project, which manages the logistics of heavy equipment transport. They integrated a connected vehicle solution that pulls a constant stream of real-time operating telemetry directly from the heavy machinery while it's out in the field. By running that continuous data stream through the cloud, they streamline their transport routes and drastically reduce overall fuel consumption. This system pulls telemetry data to recalculate the physical efficiency of an entire logistics network in real time, functioning far more comprehensively than a consumer GPS unit. The CEO of the Volvo Group noted that connecting their first million assets directly correlated to increased vehicle uptime, improved safety for operators, and significantly lower carbon dioxide emissions. Enterprise IoT leverages that core operational loop to alter the physical efficiency and environmental footprint of global supply chains. To separate the high-interest public hype from actual long-term industry ROI, we have to look at the global market trajectory data. This scatter plot maps IoT applications. The y-axis measures market interest. The x-axis tracks years to mainstream integration. On the left, consumer items generate high public interest, but represent a saturated market. Contrastingly, industrial applications like predictive maintenance take longer, but are massive-scale drivers. While consumer gadgets capture tech headlines, the massive scale of civic and industrial IoT is the primary engine of data-driven growth and long-term economic efficiency. But there is a critical friction point to this massive scale. The exact architecture that makes IoT powerful, that constant two-way cloud communication, is also its greatest liability. Consider a standard IP security camera. A breach follows 4 phases. First, hackers compromise the IP address. Second, they seize physical hardware control. Third, they siphon off the captured video data. Finally, they block legitimate users from accessing their own devices. Multiply that vulnerability by millions of devices. Widespread lack of standardization and compatibility issues across manufacturers exponentially compound these privacy and security risks. Maintaining modern infrastructure now requires a constant effort to secure massive data pipelines against systemic disruption, alongside traditional engineering and hardware management.